Hello everyone, welcome to this problem solving session of the course Digital Electronics and Circuits. And in this particular session, we would be looking at conversion of various flip-flops. During the course, we already looked at how do we convert a D flip-flop into a JK flip-flop, right? Basically, we converted a D flip-flop into a JK flip-flop. And what we did was we used the characteristic equation, which is qt plus 1 is equal to d for d flip flop, qt plus 1 is equal to jq bar plus k bar q for jk, and qt plus 1 is equal to t XOR with qt for t flip flop. When we converted a d flip flop into jk flip flop, we simply said the input d could be supplied equal to jq bar plus k bar q to convert a JK flip flop in a D flip flop into a JK flip flop, right? Now let's take another example, right? Now the problem is like we have to convert a D flip flop to T flip flop. And how do we achieve this? Converting D flip flop to any other flip flop is pretty easy, right? And this is mainly because what we can simply do is we can simply say that since D has to be converted into T flip flop, we have a D flip flop with input Q. This is Q bar. This is a clock, right? So what should we do to the T input so that this particular D flip flop works like a T flip flop with output Q and Q bar, right? So in this particular case, what we can do is we can simply compare the characteristic equation, and we can say D has to be equal to T XOR with QT, which is nothing but T XOR with QT is T bar QT plus T QT bar, correct? In this particular case, what we can do therefore is the input of D could be supplied as T and not of QT. We AND it and we OR it later, and this is supplied to a flip-flop input D, and the second input over here is again AND of two functions, and that is T bar and QT, and this Q bar and Q bar T is nothing but these are the these state of the flip-flops, right? This is one example. Now the second example which I wanted to talk about was converting a, we have already seen how to convert D into JK, but now let's see how do we convert JK flip-flop to D flip-flop, right? Qt plus 1 in JK flip-flop is JQ bar plus K bar Q, right? And Qt plus 1 in D is D. So basically what this means is the output, the next state in D depends only on the input, whereas in JK flip-flop, the next state depends upon both inputs as well as the present state. So basically if we have to convert a JK flip-flop to D flip-flop, what should we connect to the input of J and K so that next state depends only on input and not the state, right? For us to be able to do, right, what can we say if we have to do such a operation? What we have to do is somehow we have to eliminate this qt from this qt plus 1 equation, and in order to eliminate this, right, we know a simple property like any number odd with its complement is always equal to 1, right? For us to be able to do this, what we need to do, we need to have a common factor over here, and we need to take out particular things. So basically if I say k bar is equal to j, right, if in this particular equation I substitute k bar as j, so what will happen? Qt plus 1 will become jq bar t plus jqt. This will be like we can take j common, commutativity low, plus q plus qt, this will be equal to j, right? So in this particular, by doing this method, what we have done is we have made the next state independent of the present state. It only depends on an input j, and if we make this j equal to d, and that would mean my k bar is equal to j, which is equal to d. This implies k is equal to d bar. So basically if we supply j is equal to d and k is equal to d bar, we can convert a jk flip flop into a d flip flop. So basically k clock q bar. So this is equal to d is equal to d bar. So we have converted a JK flip-flop into a D flip-flop. Hope you like this problem solving session. Thank you.